Welcome to the second section of Binance Academy's intermediate course, Blockchain Deep Dive. In this section, we'll explore the intricacies of blockchain technology's interoperability and scalability, as well as the solutions and challenges that address these concerns across 4 modules. At the end of this section, you'll have a comprehensive understanding of the blockchain scalability trilemma, the trade-offs linked to various scaling approaches, and solutions that have helped achieve seamless blockchain interoperability. Since the first blockchain, the Bitcoin network, was launched in 2009, developers around the world have built thousands of blockchain networks that fulfill a wide range of use cases. While the growing number of blockchain networks add immense value to the thriving Web3 space, this has brought about one unique challenge. How can users benefit from a variety of networks seamlessly when each blockchain operates in a silo? We've learned how a single blockchain network operates in the first section. Now let's take a closer look at how they interact and communicate with each other so that users can transact across a range of different blockchains. Blockchain interoperability refers to the ability for blockchain networks to communicate with each other. Just as highways facilitate the movement of people and goods between cities, blockchain interoperability enables the exchange of information and assets among different blockchain networks. For instance, blockchain interoperability would enable someone to hold the equivalent of 1 Bitcoin on the Ethereum network as wrapped Bitcoin. Without interoperability solutions, users have to rely on a centralized intermediary to exchange Bitcoin for Ether, which can be inconvenient, costly, and introduces centralized risks to a decentralized system. How is blockchain interoperability achieved? There are many solutions, including cross-chain communication protocols, atomic swaps, and blockchain bridges. Let's first review how these 3 solutions work. Cross-chain communications protocols are designed to enable seamless interactions among different networks within a particular ecosystem. For example, Cosmos uses the Inter-Blockchain Communication Protocol, or IBC, to facilitate communication between interconnected networks within its ecosystem. Atomic swaps allow for the trustless exchange of cryptocurrencies between different blockchains. These swaps generally utilize smart contracts to ensure that both parties fulfill their obligations in a transaction without the need for third-party intermediaries. The term atomic refers to the fact that the swap process is either completed successfully or it does not happen at all, ensuring that neither party is left at a disadvantage. Users can conduct atomic swaps on decentralized crypto exchanges. A blockchain bridge, much like a physical bridge, connects 2 blockchain networks so that cryptocurrencies can be used on networks they're not native to. There are several types of blockchain bridges. For now, let's focus on token-based bridges, which allow for the cross-utilization of tokens between different blockchains by creating a tokenized representation of the original asset on the destination blockchain. Token-based bridges can be used to mint any wrapped token to represent another token or coin on a different blockchain. This wrapped token can be redeemed to get back the original token, therefore enabling a form of cross-chain communication. For example, wrapped Bitcoins are ERC20 tokens on the Ethereum blockchain that represents Bitcoins, maintaining a one-to-one peg with the original asset. When you bridge 1 Bitcoin to an Ethereum wallet, a bridge contract will lock your Bitcoin and mint an equivalent amount of wrapped Bitcoin in the form of an ERC20 token. This means you're creating a tokenized representation of Bitcoin on the Ethereum network so that you can then use the wrapped Bitcoin on Ethereum. The process of unwrapping a wrapped Bitcoin is called redeeming or unwrapping. This can be done by depositing wrapped Bitcoin on an exchange that supports the redemption process and initiating the burn. Once the transaction is complete, the wrapped Bitcoins will be burnt and the unwrapped Bitcoins will be deposited in the user's wallet. It's important to note that you may receive less Bitcoin than your original wrapped Bitcoin due to conversion rates and fees. Other types of blockchain bridges include one-way bridges that only allow you to send assets to another blockchain but not send it back to the native chain, and two-way bridges that allow you to send assets back and forth. Bridges can also be custodial and non-custodial, depending on how the bridges manage and secure the assets. Other interoperability solutions include sidechains, which use a two-way peg to connect different blockchain networks and transfer assets from one chain to another. Hash-time-locked contracts use time-based smart contracts to open a payment channel between blockchains. Custom bridges provide specialized solutions that are specifically designed to connect two or more blockchain networks. While these are the most prominent solutions that address interoperability at the moment, it's important to note that these solutions evolve quickly. New solutions emerge constantly, and the way that they are classified also changes rapidly. Blockchain interoperability is critical to allow different blockchains to interact and communicate with each other, enhancing the overall scalability of the entire ecosystem. By enabling cross-chain communication, users can easily transfer assets between blockchains without going through intermediaries or converting tokens. It also fosters innovation by allowing developers to build new applications that leverage multiple blockchains, which could increase mainstream adoption. However, blockchain interoperability has some limitations, including technical challenges and security concerns. Achieving true interoperability is a complex technical task attempting to bridge various consensus mechanisms, data formats, and communication protocols. Cross-chain interoperability solutions could also expose blockchain networks to security risks, as vulnerabilities in one chain could affect other connected chains. Governance is another challenge because different networks could face conflict and coordination problems when interconnected. As blockchain technology matures and adoption grows, the need for interoperability will become even more critical. As demand grows, we can expect to see more cross-chain solutions emerge. There could also be more standardization efforts to streamline cross-chain interoperability solutions. Now that we've learned how blockchain networks communicate with each other, let's examine the critical challenge facing blockchain networks called the blockchain trilemma in the next module.